Welcome to today's Explainer. We're jumping straight into a literal game changer today, a groundbreaking technology called AirJoule that is quite literally pulling pure water out of thin air. We're looking at a platform that sits right at the critical intersection of clean water access and industrial energy efficiency. It is completely redefining how we think about the very air around us, and honestly, the implications for our global energy and water crises are absolutely massive. So what if the solution to global water scarcity is floating invisibly all around us? It sounds a bit like sci-fi, right? But the atmosphere holds an untapped ocean of water that high-tech industries are practically begging for. As global freshwater constraints get tighter and tighter, we just can't rely solely on what's in the ground anymore. The solution is actually hovering right above our heads in the form of atmospheric humidity. We just needed the right tech to harvest it economically. To break down exactly how we tap into this invisible gold mine, we'll walk through 5 key areas today. First, the invisible water crisis. Second, the magic of sourcing. Third, how the vacuum system works. Fourth, turning waste into water. And finally, scaling the climate solution. Let's get right into it. Part 1. The invisible water crisis. $20 billion. That's a massive number. And believe it or not, that's exactly what the U.S. Department of Defense spends every single year on corrosion-related maintenance alone. Why? Simply because they cannot effectively control the moisture in the air around sensitive equipment in their storage depots. The incumbent tech, these massive traditional desiccant reels, well, they're expensive and incredibly energy-intensive to run. That is a $20 billion problem just waiting for a smart technological fix. But, the immense pressure isn't just on the military. Think about data centers. They are drinking millions of gallons of water daily in already stressed regions just to keep their servers cool. And the industry is projecting up to 30 gigawatts of growth by 2030. To put that into perspective, a single 100-megawatt data center can generate anywhere from $3 to $5 million per day in a revenue. But right now, many of these massive builds are completely stalled out, simply because they can't get municipal water permits. Which brings us to part 2. The magic of sorption. So, the crucial point here is figuring out how we extract this atmospheric moisture efficiently to clear up that industrial bottleneck. And that's where the fascinating science of sorption comes in. Simply put, think of sorption like a highly engineered, microscopic sponge that is exclusively attracted to water molecules, effortlessly pulling them right out of the air. Older vapor compression systems are total energy hogs, but AirJoule's advanced sorption technology captures water vapor from ambient air without needing external heat. It's a highly energy-efficient, refrigerant-free solution. The real secret weapon behind this entire process relies on proprietary metal organic frameworks, or MOFs. These custom MOFs are advanced sorbent materials that coat the system's contactors. They have these microscopic pores perfectly designed to trap water molecules, so the system's output is entirely dependent on this remarkable material's ability to pull water out of the air at incredible speeds. It's a real game changer. Part 3. How the vacuum system works. Let's look at the actual mechanics to see how this builds from a microscopic sponge into a continuous water-generating engine, because this is where the engineering truly shines. By alternating between vacuum chambers, like the 16 separate chambers they have in their full-scale prime system, the tech creates a continuous, self-regenerating pressure swing cycle. It's beautifully simple once you engineer it right. Ambient air goes in, the moth captures the moisture, the system applies low heat alongside a vacuum pressure swing, and out comes clean, distilled water. One chamber captures vapor while the other releases it, just running around the clock. Moving on to part 4, turning waste into water. Now we reach the absolute core of why this works commercially, how the technology achieves market-leading efficiency by utilizing what other industries literally throw away. The leap in efficiency here is undeniable. Older tech, like conventional desiccant wheels, needs 120 to 150 degrees Celsius to regenerate, but AirJoule regenerates the sorbent at just 60 to 70 degrees Celsius. They drop power consumption from over 2 kilowatt hours per liter of water down to just 0.4. That is an 80% energy reduction, meaning AirJoule can run entirely on the low-grade waste heat dumped by data centers or gas turbines. They're turning literal exhaust into pure water. As Dr. Pete McGrail, the CTO, summarizes perfectly, this is a transformational technology. We are completely decoupling water generation from the traditional municipal water grid and the high-energy fossil fuel grid. When you can tether a system to the free waste heat coming off a combined cycle gas turbine or a reciprocating engine, you're not just saving money, you're creating a truly closed-loop system of efficiency.
And finally, part 5, scaling the climate solution.
So how do we take this brilliant physical chemistry and actually deploy it across the globe? Well, let's look at the hardware. This isn't just a lab experiment anymore. We are looking at the first full-scale AirJoule Prime system built at their Newark, Delaware facility. This single unit produces about 2,000 liters of water a day. And what's really brilliant is that outside of their proprietary sorbent-coated contactors, the entire system is built using standard off-the-shelf components, normal valves and pumps. This makes it incredibly easy and cost-effective to manufacture at massive scale.
And the real-world applications are already happening, and they're vast. Down in Hubbard, Texas, they're generating drinking water using 140-degree geothermal well water waste heat. They're deploying Prime units to a net zero innovation hub in Europe specifically for data centers. The US military is looking at it for resilient water supply. Actually, think about the math for a second. A hyperscale 100-megawatt data center campus could deploy a fleet of these systems, capture its own waste heat, and completely remove itself from the local water grid. That's huge. By packaging this whole technology into modular, high-capacity shipping containers, industries can simply stack as many as they need to achieve total water independence. It's an ecosystem of solutions designed to be distributed exactly where the need is greatest, providing resilient on-site water generation without those punishing operational costs.
I want to leave you with this final thought today. We spend so much time and energy fighting over the dwindling water below ground, but maybe the solution has been floating around us all along. The next time you feel a warm, humid breeze, just realize you might actually be feeling the future of our global water supply. Thanks for joining me on this explainer, and keep looking up.